This video is for learning target 2D, which is growth and dynamic homeostasis. While there's a lot going on in this learning target, the main thing we're focusing on is the immune system. So there are other aspects, but I would say that chapter 43, the immune system, is the biggest component of this particular learning target. So this video will be broken down into the two main divisions of the immune system, which are the non-specific part of the immune system and the specific immune system. Our non-specific is going to be very general and is going to be composed of things such as our mucus, saliva, and so on, whereas our specific is a very targeted response to disease and infection. And this component is actually what allows us to become immune to diseases that we've already fought. So, for example, once you have the chicken pox, you never get the chicken pox again. Well, that's because our body has now become immune to it through our specific immune system response. Before moving forward, I did want to note that there are a couple words that have several different names, so it's important to be able to identify both. So the first one is the adaptive immune response, is the same as the specific response. And then the innate is the same as the non-specific, which makes sense because we think adapt kind of changing over time. That's what happens in our specific response. Whereas innate is something that we are born with. It's something that's just there, which would be our non-specific. The second word that I do want you guys to know is that humoral response also is known as the antibody-mediated response. Okay, I'm going to go into the specifics of our non-specific and specific response. And I want to just do audio for this because there are a lot of vocab terms and new words being introduced here, so I want to give you guys the pictures that go along with that. To begin, our non-specific response does a lot that we probably have never considered or thought about. For example, this is going to include our skin and mucous membranes that our body uses actually to fight against foreign cells and viruses. So we secrete oil and sweat through our skin, and that actually gives our skin an acidic pH that ranges from 3 to 5. That acidity basically discourages microbes from wanting to be on our skin. Also, we have saliva and tears and mucus, and that all contain this enzyme that's on the left-hand side of this image, which is lysozyme. And that lysozyme actually destroys bacterial cell walls. And if the bacteria doesn't have a strong cell wall, it will actually burst or rupture and is no longer viable to attack our body. Mucus is also able to trap foreign particles and microbes and transports them to the stomach. Now, our stomach has a lot of enzymes and good bacteria that actually break down those microbes. In addition to this, we have white blood cells that can also be part of our non-specific defense. We have something called macrophages, which are on the right-hand side there, that picture, which are really just large white blood cells that circulate through our blood looking for any foreign material or foreign cells that it will quite literally just engulf through the process of phagocytosis, which should be a review for you. That whole process is being shown in that picture there. As you can see, the bacteria is in full force on the left-hand side, is being engulfed into the cell, and in the middle of the cell, lysosomes are actually breaking it down, and then the non-harmful particles of whatever's left over, broken down material, it's just matter at this point, is then released and doesn't hurt our bodies. So our macrophages are also called antigen-presenting cells because of, so you're going to see that in APC quite often.
because they have an ability to display on their own cell surface the proteins that were on the surface of the cell or viral particle that they had just digested themselves.
Okay, so what is the purpose of being an APC or an antigen-presenting cell? So our macrophages are just roaming around throughout the bloodstream and have just engulfed some foreign bacteria. Now, as I mentioned before, we have both a nonspecific and a specific response to some foreign antigen in our body. They work together, so this is the macrophage's way of communicating with T cells in order to get our specific response going. So the macrophage will take those proteins from that particle that it's just digested, and then it literally displays those proteins on its exterior, as you can see in that picture on the very right-hand side. Then those T cells will come up and recognize that and can identify that foreign protein that the macrophage has encountered. And then from there, that specific response, that the specific defense will be activated, and now our whole immune system is working together. Looking at the specific immune response, we have that response broken down into two separate categories. The first one is our humoral response, and then second is our cell-mediated. Now, as always, I am going to reiterate the importance of understanding the roots of all of these words we're learning about. And if you don't know them, look them up. It takes 2 seconds, and it tells you a lot about what's actually happening in these responses and in these processes in general. So for example, our humoral response, that root humor actually means the body fluids in bio. So what's happening in our humoral response is that we are actually getting antibody secretion or the production of antibodies and it's released into the bloodstream, which is fluid. So our humoral response, antibodies are secreted into the bloodstream. This is going to work with our B cells, and I'm going to break up humoral and cell-mediated responses and go through those a little bit more thoroughly, what's actually happening each step of the way, but this is just a little bit of an overview. Our second response here, cell-mediated. This involves the direct killing of cells that have been exposed to antigens and are a threat to our body, and includes the overall activation of the immune system. As opposed to B cells, now we are using T cells for our cell-mediated response. Both of these responses are crucial and are actually working together. It's not one thing or the other, so they actually communicate in order to help our body fight an antigen in our specific immune response. Both of these have something that we call a lag period. A lag period is basically the amount of time that our body needs in order to get ready to fight that infection, that exposure to the antigen. So think of it just as if our country was going to war. Most countries, we would need some time to get ready. We are not just ready to go immediately once something occurs. We need to get all the troops, we have to call in extra support, we need to get weapons ready, and so on. Our body needs the same time. Our response doesn't happen immediately. So we have that lag period. Now, there is a big difference between the primary response and the secondary response. Our primary response is when we are exposed to an antigen for the very first time. We've never seen this before. Our body is unfamiliar with it. Our body actually needs 7 to 10 days in order to get ready to fully fight that infection, the antibody secretion, actually getting those T cells activated and reproducing. We need 7 to 10 days that first time we're exposed to something, some antigen. That's a really long time. So what happens is after that, 7 to 10 days, we fight that infection. Now the last step in both our humoral and cell-mediated responses are to create memory cells. In those memory cells, what happens is basically our body is able to remember what antibodies need to be produced to fight that antigen. And those stay in our body for decades. So if we get exposed to that same antigen a second time, we have something called a secondary response or secondary exposure. Instead of it taking 7 to 10 days to kind of get the troops ready, it takes 1 to 4. That's all. And within those 1 to 4 days, you're actually going to have a better response than you even did that first time you were exposed. So primary response takes a long time to fight that infection. Secondary exposure, really quick. Now, this is kind of our idea behind vaccinations and why we do this. If you go to the doctor's office and they give you your vaccine, they're actually exposing you to a small amount of those antigens. Now, if our body is exposed to those antigens, we respond. It takes a while, however, we go through this whole process and eventually create those memory cells, so the next time we're exposed to it, we have a secondary response as opposed to a primary response. Basically, you still could get that antigen, but your body is able to fight it much quicker. Just like the flu vaccine every year, they change it because there's several different strains. However, what they're trying to do is expose you to a little bit of the flu, and that's why often after you get a flu shot, you feel sick, you feel a little bit of the flu. It's because you actually have the flu, just a small amount of it. So hopefully, if you get exposed to the flu during that flu season, you get a secondary response and you don't end up sick in bed for a week. So that's why I personally would recommend always getting your flu shot. I always do. Now, what happens if you get sick, you didn't get a vaccine, and you go to the doctor? Well, oftentimes, they will give you a shot at that point. What that actually is are they're pre-made antibodies. So instead of having to go through this whole process, they have pre-made antibodies for certain infections or antigens that can just be put into your body and you're ready to go and fight that infection. So it's a much quicker process because you're speeding this up. So fun fact about those, they're actually oftentimes prepared in other animals, such as horses, and then taken out and injected into us. They're prepared antibodies.
The last thing that I want to do is take you through the exact steps of the specific immune response, also known as the adaptive immune response. So the first step is that there's a threat. There's some foreign cell or molecule entering into the body. The next thing is that threat has to be detected, and that is the role of the macrophage, which at that point will also engulf it. Now, as I mentioned earlier, macrophages have that very specific capability in which they're able to actually put that antigen from the particular pathogen on its surface of its cell. This is when it's going to do step 3, which is alert the rest of the body. The macrophages are actually then going to present those antigens to helper T cells, in turn activating those helper T cells. After that, we have step 4, which is where the rest of the body or the immune system is alarmed. The helper T cells are actually going to activate at this point both lines of defense to help fight that specific antigen. We move into step 5, which is building our specific defenses. Remember, this is going to take time, and this is why when you're sick, you're not better immediately. You need that time in order to prepare your body to fight this infection. So the humoral defense, also known as antibody-mediated defense, is when our B cells are activated and start dividing to form the plasma cells. And the cell-mediated defense is when T cells are dividing to form cytotoxic T cells that are going to attack cells with that specific antigen. Once we get through that period of time in which the defenses are being built, we can actually go ahead and attack the antigen at this point. So the antibody-mediated or humoral defense is when those antibodies that were already created that were specific to the antigen eliminate that antigen. And then the cell-mediated response is when those cytotoxic T cells that were just formed cause the cells with the antigen to burst. Notice that slight difference there, that the cytotoxic T cells are focusing on the cells with the antigen, whereas the humoral response is when the antibodies are fighting the antigen, not the cells with the antigen. There is a small difference there. Next, we move into just a continued period of watching what's going on, making sure that nothing else happens. So when those helper T cells and cytotoxic T cells and B cells were activated originally, memory cells were also created. Those memory cells will just hang around and simply watch and make sure nothing happens. And if it does, there's another attack, then it will be able to respond much quicker this time around. Our last step occurs once the antigen has been destroyed. Once this has happened, the suppressor T cells are going to shut down the immune response for that particular antigen. Yay, you made it to the end of the immune system video. I hope this helped you out.